Hi, welcome to this lab experiment. What's it about? Well, what we're going to do is this. We are going to test and compare two samples of water. One, bottled water, Arrowhead, probably heard of that one. The other, outside this classroom at St. Anna College, there is an ornamental fountain. Do you know what an ornamental fountain is? It's like where the water sprays up and then trickles down, something visual that people like. That's the ornamental fountain. It's over there by the administration building. When you're at SAC, take a look at it. This is where one of the two samples came from. What's going to happen is we are going to test these two samples for, let me look over here, pH, chlorine, copper, hardness, and iron. In the lab, you can read about every one of these. Now, I printed part of the lab, even though the lab that you're taking with me is an online lab. Nevertheless, in the module, if you look, you can see that there's an entire layout of the lab. You can print it. You can just read it. Whatever way you want to deal with it, it's fine with me. Make sure you do go all the way through it and read the whole thing before you answer these questions. So as I said, I printed the lab so I can see what the questions are, but you'll be able to see them too. If I was you, I would probably open kind of a split screen, have this video going simultaneously on the other side of the screen, have the lab open so that you can see these questions and you can answer them, okay? I'm going to read some of this experiment. I'm not going to read it all, you can read it. I've already done it, more or less, so it's just a matter of us going through it together. And what's going to happen is I took water from each one of these samples, A and B, okay? Sample A right there. Sample B over here. One of these two is the bottled water. And this is, as much as anything, about your expectations for bottled water. When you buy a bottle of water at the store, what do you expect that you're going to get? In comparison to, for example, an ornamental fountain like what we have outside. If you have an ornamental fountain, you have to treat the water, right? Yeah, because it's like a swimming pool. And you don't want that water in that fountain getting kind of funky and green and weird or having mosquitoes in it or whatever any more than you want that in a swimming pool. So my assumption is that they have treated that water out there. We're going to see whether they have or they have not. But I have an assumption that they probably have. What are your expectations for water that's treated for an ornamental fountain or a swimming pool for that matter? And what are your expectations for water that comes like this, Arrowhead, in a bottle? What are they? Okay, I have some, and you probably have some too. So what happens is we pour a sample of water from each one of these two samples into one of these little baggies, fill it up to the line where it says to be, and we put in one of these little pills here, shake it around, and then you get, for example, some color. Kind of cool, huh? I like it too. Where's the straw at? I'm going to have to run over there to get the straw. Okay. Well, I'm going to have to leave you in a moment to get the straw. But that's all right. We'll start. So I'm going to read it, and you can read along with me. Quality water is colorless, tasteless, and odorless. Odd colors, tastes, and smells are impurities in the water, which does not necessarily mean those things are dangerous. They just aren't water. So what you're going to do with me is complete the following exercise. All right, and we're going to start with part one, testing pH. This is called the tap water tour. Right there, see that? So what's going to happen is we are going to compare the colors we got to each one of these color codes on the tap water tour. So for pH, chlorine, copper, hardness, iron, you're going to record them and of course answer the questions on the quiz. So let's start with this. So it says for part one, using one of the sample bags, that's this part, with the yellow twister at the top, pour water in from the beaker labeled sample A. That would be this one. To line C on the bag, you probably can't see this, but there is indeed a line C right there. Okay, line C on the bag. Remove the pH wide range. pH wide range. So you remove one of those pills, put it in there, and shake the bag around. And when you shake the bag around, you're going to get some kind of color. Remember, you're trying to discern whether it is sample A or B that is the water that comes from this bottle, because the other water is going to be the ornamental fountain, based on your expectations. Okay, so let's try it. Whoops, sorry. What is the pH of your samples? So are they acidic, basic, neutral? If you read the lab, then you know the difference between these things on the pH scale. So let's start with sample A. This is sample A. Oops, drop the paper. See, this is what happens when you do things live. Things can go wrong. So there's the pH scale right there. And here is sample A. Which color does sample A look most like? Can you tell which ones it look most like? Any of those? And you probably know that the pH scale is a 1 to 14 scale if you read. This is 4 to 11. That's all right. Okay. That's sample A. Record it. Let's take a look at sample B. This is sample B. Take a look here. Oh, these are a tough one. Oh. Okay, very good. So record that. That was a tough one. I don't know. You have to be creative with that. Look at the pH in figures 1 and 2, and what substance do these samples correspond with? So you're going to look at figures 1 and 2, and on figures 1 and 2, it gives you some things. For example, if it's a 4, what other things are like a 4? That's what you're going to record there. Okay, very good. Now, look, this is critically important. Gently open the plastic bag for sample A, take one of the straws, and blow into it for 60 seconds. All right, I got to go grab the straw. Hold on. I wish I could tell you a joke right now, but I don't know any jokes. Let me find the straw. You can see me running around the classroom. Looking for it. Here I am, looking for the straw. There's the straw. Got it. Illegal in California, right? We're not supposed to have straws. There we go. Very good. Oh, all these drop downs are coming around. I don't want any of that. So we're going to take sample A, and I am now going to do what it said, which is blow into it for something like 60 seconds. There's a clock over there. I'll try and watch. Okay, so watch. Straw goes in. Now I do this. Don't inhale. Something's happening. Okay, look at that. Something definitely happened. It changed colors. So, what is the new pH? What do you see as the new pH? New pH. Record that. Okay. For A. And you can see, remember I have a hard copy. You're looking at it online. What happened to the color of the water for sample A? First of all, what happened to it? And what is the new pH? And number 5, you have to answer for both of these. Why did the pH change in each sample? In other words, what is in my breath? Come on. What is in my breath that's being added to that water? In other words, when you exhale, what are you exhaling? What is that? What do we call that stuff? It comes out when you breathe out. Okay, let's try the other one. Sample B. We're going to do the same thing right now. Open the sample up. Oh, isn't this fun? We're going to open this. There, almost. There it is. Okay, pull on these two guys here. Now it's open. Come to me, you little straw. Let's see what happens. In you go. Here we go. Whoops, have to get in the water. Wow. There's a lot of effort for that. Let's see. Did the color change? Not much, huh? What would be the new pH? That's a tough one. All right, there we go. That's that. That one's done. That over here. Next. Test you for chlorine. So now we're going to do the same thing, but we're going to do it with chlorine, but we're not going to blow into it. So this is sample A. This chlorine's at up here, the top, in the middle. I'm going to fold it, though. You can see this is chlorine right here. Fold it so you can just see this part right here. Remember, one of these is bottled water, the other is not. Chlorine, what do you see? How would you record this? Obviously, if there's nothing there, it's below low. Okay, very good. That was for sample A. Recorded for sample A. Now sample B, but you're going to see something here. Woo! Wow, look at that. Sample B. What does sample B look like? There you go. Good. That's sample B. Next, copper. All right. So here we go with copper. This is sample A with copper. Here's a chart. There we go. Oops, sorry. I'm doing this. You know, when you do this, it's backwards, so it's a little difficult to see what's going on. This is sample A. Which one does it look most like? Sample A. Sample A. Good. Sample B. Sample B. What do you see for copper for sample B? Okay, very good. Next is hardness. You can read about what hardness is in the lab, tell you a little bit about that. It's a good thing to know. A lot of people in Southern California have hard water anyway. I have hard water at my house. Makes that scaly white stuff that you have to get off with lime away. Okay, there's sample A. What does sample A look like? Which one do you see sample A looking most like? Sample A. Good. Let's try sample B. Sample B. Wow. Sample B is a trip, isn't it? Sample B. Wow. Okay. And finally, iron. Same thing with iron. Here we go. Iron. Sample A. What do you see for sample A for iron? Imagine if you don't watch this, you're going to try and fill this in. Wow. Are you ever going to be tricked? There we go. And then sample B for iron. Not a lot of difference. Not much water and not much iron in these samples of water. All right? Awesome. Good luck. The table shook. That was not an earthquake.